All right, so today we kick off our review for the final exam. We will have 4 formal review sheets that will be linked as PDFs on Schoology. On each of those review sheets, you will see some formulas, good things to know, and then there'll be questions, and then just like a study guide, there'll be worked out answers in the PDF as well. Each day that we have problems, we will have a video that goes over a couple of those problems, kind of like as if we had been in class. We'd go over a few problems just to refresh our memories and then give you a chance to work. So there'll be a chunk of problems, and a few of those we will do in a video, and then the rest you'll finish on your own and then upload them to Schoology for your assignment. We will have 5 review quizzes. They'll be on days 3, 7, 10, 13, and 14 of review. And then after we do each of the review packets and the review quizzes, then whatever days we have left, we'll just do some additional problems to get ready for the final exam. Each morning at 10 a.m., I will hold a live video chat for questions that people have regarding the previous day's work. So you need to stay up to date with the review. You need to be doing it each day. And if you have trouble on any questions, if you're not sure how to do it, you need to take the responsibility upon yourself. Get out of bed, get to the video chat at 10 a.m. so you can get your questions asked. Because if you don't do that and then it shows up on the final, you're not going to be able to answer those questions. So that's what we'll be doing each day. We'll have problems, we'll have video chat, and the only days we will not have a video chat are the days after quizzes, because you won't have any new problems for that. Or actually, maybe we'll still have the video chat the day after quiz to go over any questions you had from the quiz that you were unsure of. Okay, so for today's work, this is day 1. We are going to be doing together, we're going to do questions 7, 13, and 15, and then in totality, you're going to have to submit questions 6 through 16. So you should be doing that on a separate sheet of paper. You don't have to print out the review sheets if you want. You can just have them open. You should be doing the problems first and then checking your answers. So first off, the formulas that we have here, we got some basic derivative rules. We got our trig derivative rules. Some important limits to remember. This first limit here is the main one. If we have like x approaches 0 of sine x over x, that was always 1. Newton's method you don't have to worry about because we won't have calculators on the final, so I won't give that. And remember, for your inverse ones, the important inverse ones are sine inverse and tan inverse. Those are the 2 that I would test you on potentially on the final. So we're going to start out, we're going to look at number 7. So we want to find the limit algebraically. So finding limit algebraically, there's a couple ways we did this at the start of the year. You could have factored and divided things out. We could have looked for one of our special limits, like the sine x over x as x approaches 0. If we have separate fractions, we got common denominators and brought them together. And then there's this case here where we had radicals being added or subtracted. If we try to do direct substitution here, we're going to get 1 minus 1 in the numerator and 0 in the denominator. So because it's given us a 0 in the denominator, the technique we learned early in the year to do this would be to multiply by conjugates. So we can multiply by radical x plus 1, both top and bottom. Each time we should rewrite our limit. Now, when you multiply by conjugates, the whole purpose of doing it is the inside and outside terms will cancel out. So if we do our firsts, the radical times the radical will just be x plus 1. Our inner will get a positive radical, or sorry, the inner is a negative radical, the outer is the positive radical, so they end up wiping out. And then negative 1 times 1 just gives us negative 1. Just note, when you multiply your lasts, if that's where the radical was, you'd have to distribute the negative through. And then we're all over x And the spot where you were not taking the conjugate of, you never want to multiply that out. Because if you do, then you won't have what you need to divide out eventually. So this is, if we combine like terms in the numerator, we just get an x. And notice how by not multiplying out that denominator, we have an x that will divide out. So this now becomes limit as x approaches 0 of 1 over radical x plus 1 plus 1. And now we're going to do our direct substitution. When you do direct substitution, that's when you no longer write the limit. So we'll have 1 over, we'll get radical 1 plus 1, which is the same as saying 1 half. Now, technically, L'Hopital's is also an algebraic method. These early ones, I would ask you to try and do the methods we did in Unit 2, because we'll see some L'Hopital's ones later on. But on the final, if it said find the limit algebraically, it could be one of our early methods we used, or you could use L'Hopital's if it was a L'Hopital's case as well. So the next one we're going to look at is 13 on review sheet 1, and it's an inverse tan one. Our derivative rule for basic inverse tan was 1 over 1 plus x squared. And we've said to think of that as 1 over 1 plus stuff squared. Because really we've got a chain rule here. We've got an x to the fourth inside. So when we go to do this derivative, we're going to have 1 over 1 plus stuff squared. Well, our stuff is x to the fourth. So x to the fourth would go in here. Because of chain rule, we got to multiply afterwards by the derivative of our stuff, the derivative of our inside. So we're going to multiply by 4x cubed afterwards. You can either leave it like this, that'd be perfectly fine, or if you wanted to neaten it up, we'd have 4x cubed over 1 plus x to the 8th. Okay, either of those would be full credit answers. And then we'll do 15 as our last one in the video. So when you want to do a derivative, if you've got a trig function raised to a power, remember rewrite that as the trig function, all in parentheses, and then raised to the power. It will make it easier to recognize that it is a chain rule case. Our outsidemost part is the raised to the third. So when we do the derivative, we're first going to do our derivative of something raised to the third. So 3 comes out front, and the inside stays the same. That's our first thing we should do. And now we're raised to the second. But now we got to do times derivative of the inside. So we got to do derivative of sine 4x. Well, in sine 4x, the outermost part is the sine. So derivative of sine is cos, keeping the inside the same. Then we've got to do times the derivative of its inside. So derivative of 4x is just 4. You could leave it just like that, or if you wanted to neaten it up, you could do 12 sine squared 4x times cos of 4x. And remember the different things that represent derivative. You got dy dx, f prime x, y prime. All those could mean the derivative. So that's it for review video 1. So again, you've got problems 6 through 16, and we just did 3 of them here.